Now it appears that uh, if we add more number of regenerative repeaters, the performance would be better. But problem is, since we have deciding, it is basically a receiver. We have to decide whether the incoming bit is logic 0 or logic 1. So there is a chance of getting error signal. That means 1 may be represented by 0 or 0 may be represented by 1. So there may be some error. Now if we have n number of repeaters within this path, n number of repeaters, regenerative repeaters, and assume that all the repeaters are identical in nature, so what happens? We can use binomial distribution to calculate the effective bit error rate or bit error probability. But instead of going to that mathematical manipulations, we will just determine, or we will just write the effective bit error probability will be n times the bit error probability of individual regenerative repeaters, assuming identical repeaters are used. N is the number of repeaters. It is approximately, not exactly. That means more the number of repeaters, more will be the error rate. That means what should be the actual number of regenerative repeaters? That is a very crucial question, and you have to select the number of regenerative repeaters, keeping in mind that if you increase the number of repeaters, the effective bit error probability will increase. Not only that, if you reduce the number of repeaters, that means if we increase this distance between one repeater to another repeater, then what will happen? More noise will come, and in presence of larger noise, the signal to noise ratio will be poorer, inferior. That means at the repeater end, there is a chance that error rate may be enhanced. So those are the problems associated with these repeaters, and you have to select the number of repeaters and distance between two successive repeaters very, very judiciously. Otherwise, there is a chance of enhancement of the bit error probability.